This video corresponds to your problem 2.3 in looking for Pythagoras. To go along with problem 2.3, you will need this lab sheet. This is the back side of the lab sheet. Get that handy and grab a pencil and be ready to participate. Problem 2.3 investigates different side lengths of squares that all fit in a 5 by 5 dot grid. The first thing they want you to do is to find all those line segments. But to save time, we have created a drawing that has all those side lengths in it. It's in the upper right hand corner of the back side of your lab sheet. We have also made a table for you to record your data. You'll need to know some things about geometry and its notation to get started. The first thing you'll need to know is that when it says line segment AB, it means the distance from A to B as part of a line. So I'm going to highlight that right now. You can do that with me on your lab sheet. If we're looking for AB, that's that blue segment right there. Now if we go down to the dot paper, we can draw a square that has all four sides being that side length. It would look like this. Each side length would be 1 unit, and you can tell from the drawing. Now is where the front side of your lab sheet comes in handy. On the front side, we have given you some boxes to draw some squares in a 5 by 5 grid. You'll notice in the upper left-hand box, you have a line segment pre-drawn for you that has a distance of A to B. Now I'm going to go ahead and make that a little bit bigger for you. And then we're going to draw the square that we just drew in that box. So you'll notice that that has the same exact area as the one we drew. It has a side length of 1 unit. Those segments are pretty easy to draw the squares and to find the areas of. So going back to the back side of your lab sheet, we know that the side length of AB was 1 unit. So we're going to write 1 unit right in the table. That was pretty easy. But when you look at segments like AF, I'm going to highlight that right here. Those are a little bit harder to draw. So let's go back to the front of your lab sheet where I have that pre-drawn for you. So you'll see AF drawn in the middle right-hand side box on the front of your lab sheet. Again, I'll make that a little bit bigger for you so it will show up better on the video. And we're going to go ahead and draw a square that all sides of the square have the same length as AF. It should look something like this. So your next task will be to find the area of the square that we've just drawn, if it's AF on all sides. So remember back to where we found areas of squares when we didn't know the side length. One of the techniques we used was to break it into smaller pieces that we knew the area of. So for example, I can find the area of this green triangle, which is exactly half of 1 unit square. So there's 1/2 square unit in that triangle. Since there's 4 of those triangles in this square, that would be 4 1/2 square unit areas, or an area of 2 square units. So we know our square has an area of 2 square units. We also remember that if we know the area of a square, we know the side length of a square. The side length of a square is exactly the square root of its area. So each side, including AF, is the square root of 2 units long. Okay, so let's go back to the back side of our lab sheet where we have our table to record our data. Let's look at our table, and we just found the side length of a square that was AF units long, or from A to F. So on our table, we're going to record that the distance of A to F, or segment AF, is square root of 2 units long. Now, your task is going to be to find the line segment's length for each line segment in your table. They're all listed here, AB, AC, AD, etc. They all have a common endpoint of A, and you're going to record those in the corresponding column on your lab sheet. And then go back to problem 2.3 and make sure you answer the questions in your book. Remember that we got you started on the front of the lab sheet with some line segments already pre-drawn. All you needed to do for those is to complete the square, find the area of the square, and then use that to find the side length of the square, which is the same length as that line segment. Then record it on your data sheet. Also remember that as you complete your table of data and answer the questions in the book, what we want you to be doing is looking for patterns or connections that you can make along these lines.